Welcome to ReneEnergy.com, your go-to destination for cutting-edge developments in renewable energy. Today, we embark on an enlightening journey into a revolutionary concept reshaping the wind power landscape: solid-state wind energy. This series aims to demystify this innovative technology, evaluate its potential, and ponder its role in the future of renewable power. Wind energy has long been synonymous with large turbines dotting rural landscapes or offshore wind farms. However, a transformative approach is emerging, challenging traditional perceptions and methodologies. Solid-state wind energy represents a paradigm shift, introducing a method to harness wind power without mechanical motion. At the heart of solid-state wind energy lies a simple yet profound principle: utilizing the natural forces of wind to generate electricity in a stationary structure. This approach marks a significant departure from conventional wind turbines, which rely on rotating blades to capture wind energy. The absence of moving parts in solid-state systems presents a unique set of advantages and challenges, reshaping our understanding of wind power generation. As we delve into the intricacies of solid-state wind energy, we will explore its working mechanism, assess its benefits and limitations, and envision its potential impact on the renewable energy sector. This series is designed to provide a comprehensive understanding of solid-state wind energy, from its scientific foundations to its practical applications. Join us on this enlightening exploration as we uncover the mysteries of solid-state wind energy. Whether you are a renewable energy enthusiast, a professional in the field, or simply curious about the future of sustainable power, this series promises to be a captivating and informative journey. The science and technology behind solid-state wind energy. In this section of our solid-state wind energy series, we delve into the science and technology that make this innovative approach possible. Understanding the mechanics of how these systems capture and convert wind energy without moving parts is key to appreciating their potential and innovation. Solid-state wind energy systems, exemplified by technologies like the Vortex Bladeless, operate on a principle fundamentally different from traditional wind turbines. These devices utilize aerodynamic phenomena to harness wind energy. The core concept revolves around aeroelasticity, the interaction between aerodynamic forces and structural flexibility. The process begins when wind encounters the solid-state device. Unlike traditional turbines that use blades to capture wind energy, solid-state systems rely on their structure's propensity to oscillate in response to wind currents. This oscillation is not random but a controlled and deliberate motion induced by the design of the device. The wind's interaction with the structure creates vortices, a pattern of spinning air, around the device. These vortices exert pressure, causing the structure to oscillate. This oscillatory motion, although seemingly simple, is the result of complex fluid dynamics and material science. The conversion of this kinetic energy into electricity is achieved through various methods. Some systems use piezoelectric materials, which generate voltage when stressed mechanically. Others employ electromagnetic induction, where the oscillation of the structure induces a current in a coil, generating electricity. Advantages and practical applications of solid-state wind energy. In this section, we explore the myriad advantages of this technology and its practical applications. The unique characteristics of solid-state wind energy systems make them a compelling alternative to traditional wind turbines, offering benefits that could reshape the landscape of renewable energy. One of the most striking advantages of solid-state wind energy is its minimal environmental impact. These systems operate silently, making them ideal for urban or residential areas where noise pollution is a concern. Additionally, the absence of rotating blades significantly reduces the risk to birds and bats, addressing one of the major environmental concerns associated with traditional wind turbines. Maintenance is another area where solid-state wind energy systems excel. The lack of moving mechanical parts means fewer components are prone to wear and tear, leading to lower maintenance costs and longer operational lifespans. This reliability is crucial for reducing operational costs and enhancing the overall efficiency of renewable energy installations. The compact and aesthetically pleasing design of solid-state devices opens up new possibilities for integrating wind power into urban landscapes. These systems can be installed on rooftops, alongside buildings, or in public spaces, making wind energy accessible in areas previously unsuitable for large turbines. In terms of practical applications, solid-state wind energy can play a vital role in decentralized energy systems. Its adaptability makes it suitable for a range of environments, from powering remote communities to supplementing the energy needs of urban areas. This technology's scalability and versatility allow for tailored solutions to diverse energy requirements. Challenges and future developments in solid-state wind energy. As we continue our exploration of solid-state wind energy, it's essential to address the challenges and future developments in this field. While solid-state wind energy presents exciting opportunities, it also faces hurdles that must be overcome to realize its full potential. One of the primary challenges is the current efficiency gap between solid-state devices and conventional wind turbines. Solid-state systems typically have lower energy conversion efficiencies due to their novel operating principles. Bridging this gap is crucial for making solid-state wind energy competitive with traditional wind power and other renewable energy sources. Research and development are key to overcoming these challenges. Innovations in materials science, aerodynamics, and energy conversion technologies are critical for enhancing the performance of solid-state wind energy systems. Efforts are underway to improve the design and materials used in these devices to increase their responsiveness to wind and maximize energy output. Another challenge is scalability. While solid-state devices offer advantages in urban environments, scaling them up to match the energy output of large wind farms is a complex task. This involves not only increasing the size of individual units but also optimizing their placement and integration into existing energy grids. Looking towards the future, solid-state wind energy has the potential to play a significant role in the renewable energy landscape. As the technology matures, we can expect to see more innovative applications and improved performance. The integration of solid-state wind energy into smart grids, coupled with advancements in energy storage, could significantly enhance the efficiency and reliability of renewable energy systems. Conclusion and the future landscape of renewable energy. As we conclude our comprehensive series on solid-state wind energy, it's time to reflect on the broader implications of this technology for the future landscape of renewable energy. The journey through the intricacies of solid-state wind energy has revealed both its potential and challenges, painting a picture of an evolving and dynamic field. The future of renewable energy is increasingly diverse, incorporating a variety of technologies to meet the world's growing energy needs sustainably. Solid-state wind energy, with its unique advantages and innovative approach, represents a significant piece of this puzzle. Its ability to harmonize with urban environments, reduce environmental impact, and offer new avenues for wind power generation makes it a technology worth watching. However, the path forward is not without obstacles. The efficiency and scalability challenges that solid-state wind energy currently faces are significant, yet they also provide opportunities for innovation and growth. The progress in this field will be driven by continuous research, technological advancements, and collaborative efforts across disciplines. The integration of solid-state wind energy into the broader renewable energy mix will be a crucial factor in its success. This technology's potential to complement other forms of renewable energy, such as solar power and traditional wind turbines, could lead to more robust and resilient energy systems. The synergy between different renewable technologies will be key to achieving a sustainable and carbon-neutral future. In conclusion, solid-state wind energy stands at the forefront of renewable energy innovation. Its journey from a novel concept to a practical solution encapsulates the challenges and triumphs of advancing sustainable technologies. As we look towards a future where renewable energy is paramount, the role of solid-state wind energy in shaping this future cannot be understated. We invite you to continue following ReneEnergy.com for more insights into the exciting world of renewable energy. Together, let's embrace the innovations that drive us towards a more sustainable and energy-efficient future. Thanks for tuning into the ReneEnergy.com YouTube channel. We trust you found this episode enlightening and motivating. There's a world of innovation and opportunity in sustainable energy, and we're delighted to share this journey with you. Stay in the loop with the latest on renewable energy and sustainability by visiting our website and subscribing to our newsletter. Your support is immensely appreciated, it's truly invaluable to us. Don't miss our next video on new trends in renewable energy. Follow us on social media for the latest updates. Enjoyed the video? Like, subscribe, and share for more green insights. Thanks for watching.